Hello, good morning. The spacing of adjacent lines in the multiplate is a direct measure of the spin-spin coupling and known as the coupling constant J, the spacing of the adjacent line of multiplate. It is distance between the two adjacent subpeaks in a split of signals. J value is expressed in hertz or cycles per second. The distance between adjacent peaks is called coupling constant and denoted by J. The unit of J is hertz. It is observed that J depends upon the number and type of bond and spatial relationship between the protons. Geminal proton-proton coupling for the protons attached to the same carbon, that is the geminal protons, J varies from 0 to 20 Hertz depending upon the dihedral angle and structure of the molecule. See, this is the geminal 0 to 20 Hertz geminal coupling. Basinal proton-proton coupling, protons attached to the adjacent carbon atoms, that is the basinal protons. They varies from the 2 to 18 Hertz in case of geminal, 0 to 20. In case of basinal, 2 to 18, depending upon the spatial position of the protons and structure of the molecules. See, this is the basinal in case of cis position, 6 to 14 Hertz. This is the transposition 11 to 18. This is the anti-position 5 to 12 Hertz. This is the Gauss position 2 to 4 Hertz. What is the coupling constant? What are the factors that govern the coupling constant? The distance between the adjacent peaks is called the coupling constant and is denoted by J. Coupling constant gives the measure of the splitting of effect. The values of J are independent of applied field strength and depend upon the small structure only. The unit of J in Hertz mutually coupled protons show the same value of J. It is observed that J depends upon the number and types of bonds in between and the spatial relation between the protons. Following examples listed for the protons attached to the same carbon, that is the geminal proton, J varies from 0 to 20 Hertz, depending upon the dihedral angle and structure of the molecule. For protons attached to adjacent carbon atoms in basinal, J varies from 2 to 18 Hertz, depending upon the spatial position of protons and the structure of the molecules. The protons with anti-conformation have the values J between the 5 to 12 Hertz, and those with the Gauss conformation J equal to 2 to 4 Hertz. This is the anti and the Gauss conformation. In case of vinylic protons, where there is a restricted rotation between because of the double bonds and the cis protons, J value 66 to 14 Hertz, whereas the in trans 11 to 18 Hertz. This is the cis position and trans position of the flame molecules, which is exhibit spin-spin coupling. What will be the multiplicity of each kind of proton in the source molecule? All the protons are the same type, hence the no spin-spin coupling in case of first. This is the same type of protons, so no spin-spin coupling. In case of second dibromoethane, the protons of CSBr2 is split into singlet, into quartet, and the protons of methyl are split into doublet. Protons of each methylene group are split into triplets in case of third. For example, dibromoethane. In case of chlorobromoethane, bromochloroethane. In case of bromochloroethane, the spin-spin coupling takes place because there is no hydrogen on the bromine bearing the carbon. Consequently, there is no non-equivalent protons on the neighboring carbon with reference to any methyl group. No spin-spin coupling takes place because both the protons are molecular equivalent in case of example 5. See, dichloroethane. In case of example B, I7, example 7, chloroiodethane, no neighboring hydrogen for spin-spin coupling, that is singlet. In case of VI means dichloroethane, iododichloroethane. Either two protons on the one carbon are not equivalent in split into doublet and due to mutual splitting. In case of VI chloroiodethane, two protons on one carbon are not equivalent. Each is split into doublet in mutual splitting. This hydrogen has chlorine and this hydrogen has iodine, so non-equivalent of this hydrogen. Okay, it's all about coupling constants. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That's now bye bye.